Okay, so you're given the values for A. This is the value of A. Whoops. This is the value of B, and this is the value of C. And then you're asked to evaluate this over here. And someone says, well, what are you going to do about that? I mean, you could do all the multiplications, and it doesn't look that easy to do, by the way. My suspicion there's something easier to do. That's why I'm going to go to the whiteboard and go through the steps of it. And let's write the steps down for this. The first step is to look at the abstract version of it. And the abstract version is that, A4. Let's write this over here, A4. And in the bottom you have A minus B. And then you have A minus C. Then I have plus B4. Okay, I'm going to try to simplify this first, by the way. B minus C. And then I have B minus A. Plus C4. And that's going to be C minus A. And then C minus B. Right. The one thing I noticed immediately about this over here is that it's not written in alphabetical order when you look at the denominators. Now the first one is, I'll write that down. So what do I mean by alphabetical order? I see A minus B. I like to try to be organized with this. The next one's A minus C. The next one I'm noticing is the B minus C is fine, by the way, but the B minus A is bad. It's on my order, so I'm going to factor out a minus 1. So we're going to get A minus B. So I'm going to factor the minus 1 now. It's B4. Let's go to the next one. Whoops, a little premature there. We got to look at it. And what I notice is both of them are out of order. So from the C minus A, I factor out a minus 1. That becomes A minus C. However, from the C minus B, I also factored a minus 1, so that's going to be B minus C now. So nothing's changed sign-wise because minus times a minus positive. Get C4 in the bottom. The next thing I would do, common denominator. The common denominator is going to be A minus B, A minus C. I'm seeing that there, seeing that there. And then B minus C. Do I see any of the factors? Let's take a look at that. I see the A minus B there, A minus C, B minus C. This is good. Now the question is, what's missing from the first term? And if you looked at A minus B, A minus C, let's see, B minus C is missing. I'll write that down now. Minus B4. And then what do you get? Well, let's see, I got B minus C, A minus B, so I'm missing A minus C. Plus C4. What's missing there? Well, I got the A minus C, got the B minus C, so I'm missing A minus B. Right. This is where I'm going to say it's as simple as I think I can get it. And then I'm hoping that there's going to be a reduction in the problem. And so what I'd look for is I'd look for roots, because that might be the easiest way to reduce it. And what I'm going to do is say, I wonder if I want the factor A minus B to cancel off, I'd have to have A equal to B. All right, let's go to the top and see if we can do that. All right. So if A equals to B, it's A4. Let's see, A is equal to B, so I'm going to say A minus C. What's the next term going to be? Minus, well, the B4 would be A4 now, and then A minus C. And then if I looked at the last term down, what would I get? I would get plus C4, and that would be, let's see, A minus A. What I notice about this over here, it cancels off. I mean, this and this are identical, and this is just 0. So this is a root, which means the top has a factor of A minus B. All right? Now again, this may be wishful thinking at this point, but I'm hoping that A minus C also cancels. All right, let me get my little eraser out. Erase this over here. Still looking for roots. And again, maybe wishful thinking, but I'm thinking maybe A equals C as a root at the top. Let's take a look at that over there. So it's going to be A4. Let's see, B minus A minus B4. Let's see, A minus C. I'm going to say A minus A now. That's nice. Plus, well, what's C4? C4 would be A4, right? And then you get A minus B. This is 0. And what about these two terms over here? They're opposites. That would cancel to 0. So now I got another factor, and that factor is going to be A minus C. This is all good news, by the way, because I know these things are going to be canceling off, or at least conditionally canceling. Let's go to the next one. I'm going to make an assumption over here. Let's see. I said A, whoops, A was equal to B, A was equal to C. I already did those. I got those done. And now I'm going to do, let's see what I was going to do. I did, I guess I could do B equals C, right? Did I do that one yet? No, I didn't do that one yet. I'll put that down for you. Let's see if I can do that. B is equal to C. So you get, let's see, A4. If B is equal to C, I get C minus C. I'm doing this on top, by the way. And then, let's see, minus C4. Again, B is equal to C. And then I get A minus C. And then I get plus C4. And then the A and the B is equal to C. And lo and behold, that's also a root of the problem. That's 0, by the way. So now I'll put that down for you. What's that root going to be? B minus C. Now, granted, I know this is difficult, and I find it also tedious, but there is a pattern to it. But if you want to, I mean, you could expand this thing and then, you know, divide through by these things over here. And you get something pretty nice, by the way. But it does require some work, by the way. And what are you going to get? Something pretty nice. You can get, whoops, I didn't mean to do that. You're going to get A squared. Whoops, I did it again. You're going to get A squared plus B squared plus C squared plus AB plus AC plus BC. All right, you're going to get that. Question is, now what do you do? And looking at this over here, I'm starting to realize that I get a lot of cancellations in it. And they're conditional, by the way. I want to point out that the condition's something to do with this, I don't know where that, you know, it's on my, I'm sorry, it's in the problem that they gave me the A, B, and C. And I don't have to worry about canceling these things over here because they're actually non-zero. And let me write that down now. So they're non-zero. So A minus B, looking back at that, those numbers, they don't sum to 0, by the way. And A minus C is not summing to 0, and B minus C is not summing to 0. So I get A squared. It's getting simpler each time I do it, by the way, but not simple enough for me to do the actual arithmetic. I'm doing algebra, which is kind of generalized arithmetic. So I'm looking at this thing over here, and I'm starting to realize that this has something to do with binomial expansions, all right? And what I mean by that, you know, kind of looking at it, maybe I should write that down. So, you know, if I wrote this down, A squared plus 2AB plus B squared. I'm just going to write a few of them down, by the way. And then I have to write down B squared plus, let's see, 2, I got to think now, 2BC plus C squared plus, I'm not saying these are equal, but I'm just looking at something, I see BC's in it, I see AB's, and I want to do the AC now. So I'm going to say A squared plus, let's see, 2AB, oh, no, I'm sorry, not AB, I did that one. Let me erase this over here. So again, I see BC, I see AB, and I don't see the AC yet. Put this over here. 2AC plus C squared. But these are not equal, all right? These are not equal. So I want to point out, if I were looking at this thing over here, I want to be careful. I know I'm hoping to see these things over here, but it's not equal to what's above it, or I'm not going to put an equal sign down yet. But if you were to do this over here, what would you get? You would get 2A squared. You would get 2B squared. Let me see if I get the B. Oh, it's right over there. I get 2C squared. Okay? And then what do you get? You get 2 times AB plus BC plus, I'm sorry, again, daydreaming, plus AC. All right, so I'm going to come over here. It's just double what's above it. So all I got to do now, whoops. Well, I got a little far there. This is going to be divided by 2. This will be divided by 2. All right, it's going to be the same thing above, by the way. So what does this give me? Let's write this down now. You're going to get, I'm doing these now, by the way, A plus B squared. I'm going to do this one now. That's going to be B plus C squared. And this is going to be, let's see, a plus c squared over 2. All right? Now, by the way, you might say, oh, I think this one's easier than this one. They're just equivalent. The reason I'm going to go with this one over here is I realize if I know what A, B, and C are, and I'm seeing these things over here, I'll write these down for you. A is minus root 3 plus root 5. And again, all I'm doing is looking back over the actual question now. And this is given to me. Plus root 7. I'm not memorizing this, by the way. I'm just looking back over the question. And B is root 3 minus root 5 plus root 7. And C is going to be root 3 plus root 5 minus root 7. All right? So let's write this down now. And it doesn't look that bad, by the way. For example, A plus B. What happens there? The root 3's disappear, the root 5 disappears, and I get 2 root 7's. So this will be 2 root 7's. And I can definitely square that. Let's see if the BC works out pretty nicely. Well, B plus C, I'm looking at these two now. And let's see, I get 2 root 3's, but the root 5 disappears, root 7 disappears. So I get 2 root 3's. Oh, by the way, the bottom's a 2. Plus. Let's look at the A plus C now. This is the A, that's the C. Add them together. Well, let's see, you get 2 root 5's then. Again, the root 3 disappears, the root 7 disappears. This arithmetic, I can finally do something kind of quickly, by the way. This will be 4 times 7. This will be 4 times 3. And this will be 4 times, whoop, this is square, 4 times 5. What goes over there? 2. This is going to be 2 times 7. I'm dividing by 2. 2 times 3. And 2 times 5. What do you get there? 14. You get a 6. And you get a 10, which is going to be 30. All right? And we're done. Thank you.